Okay. Hi, everyone. I'm going to present you something about master data management in Hadoop. So before I actually start, I would like to take a little survey. Please raise your hand if you are familiar with the whole master data management concept. Okay, that's good. Perfect. So I will start with a little introduction. So my name is Roman Kučera. I work for Atacama Corporation. We are a software vendor who deals mostly with data quality and master data management, and recently we have entered the big data space. You could have seen us in our booth. I've been doing with them for the last 4 years, mostly MDM projects for major banks. And for last year, I've been responsible for basically porting our portfolio to Hadoop with everything that we have, basically. For some of you, this may not sound like a long experience, 12 months of Hadoop, 4 years of MDM. But actually, like when you walk around in these conferences, and this one is actually pretty good, but typically when you go to see some bigger vendors and they claim they have like implemented tens of projects, of MDM projects somewhere, they are typically lying to you. So I think, I try to be honest. So why have I decided to give this speech? For the last 2 years, I've been attending conferences like this, and I've picked up some quotes. A lot of people doing some projects with Hadoop. They were telling me that they have problems with data quality and MDM. But also, some of them were, and I particularly like the last quote there, some of them were like, they thought that the MDM does not relate to data in Hadoop at all. They proposed that the structure is given on read. Once they are doing some analysis, they will give it the structure they need for the particular analysis, so they don't care about MDM at all. And I think that is wrong, and I will give this speech and I will tell you why it is wrong and how you should do it otherwise. So I'll start with a short definition. This is taken from Wikipedia. So master data is basically some single source of business relevant data across your company. It tries to collect the data from all of the sources around the company, and it consolidates it, creates a single repository which can be then used for all of other kind of processing, for any kind of work with the business relevant data, for example, clients, cars, whatever. Typically, the whole MDM solution consists of many parts. I will not cover all of them in this presentation, just the core. There is a lot of maintenance and data governance around it. There needs to be some data stewards who will keep the master data intact in the correct shape and so on. And there is obviously a ton of data quality. So I have 2 points of view how we look at the master data in Hadoop, and the 2 things that we've kind of covered with some of our clients. Some parts are actually really the traditional MDM kind of solutions, and the clients, they may have, I don't know, let's say 100 million records about their clients, maybe it's customer data. And they have a big MDM solution that works with traditional technologies, and it's not really, the processing is not really fast. Sometimes there are performance issues. Sometimes there are issues that they are collecting more and more data and the solution does not scale. And they are thinking whether they could have a cheaper solution using some big data technologies, for example Hadoop, to basically have cheaper MDM with the traditional sense. The second part could be really MDM on the real big data. They are collecting news sources, maybe they have Twitter messages and emails, and they have voice calls from their call center and so on. So that's like the second kind of MDM on big data. This one is like the more real big data. The first one is really traditional data, just leveraging the new technologies. So just to visualize what traditional MDM means, and this is, again, it's very simplified just for the purposes of this presentation. I may load one system, let's say my CRM, and I get some records into some data flow or some database table or something. Then I add a second system from somewhere else, and it looks a little different. And then I will add one more system, and now I have all data that has more or less the same format in some place, let's say Oracle database or something. And I do some consolidation, so it will end up looking something like this. So I did find that there were two John Does and two Jane Does in this case, and it produced my two master records down here. So it's very structured. The structure is more or less similar in all of the sources, and I just produce one single view of customer or car, patient, whatever. With the real big data, I really do not have that much similarity between the records. The records are very different. And I basically want to create, I would call it like a dossier of all information I have about given entity, given client, something. So it will have really a lot of various data in it. It may contain links to the original data sources. It will contain all of the data that I have. And I can actually keep adding to this. I will have, when I have this like master record, let's say it's a client. So I can, when I'm doing some analysis in Hadoop, I want to keep adding new computed, I don't know, segmentation or some other information that I've calculated. I want to add it to this master record, and I want to be able to access all of the information that I have on that person, on that entity, in one place. So a lot of people say they actually do not want the single view of their customer because different kind of purposes, when they access the data for different kind of purposes, they need different transformation, different kind of aggregation, and so on. This has still some problems. I think that it's true that for some purposes you may want to do different transformation, different data quality checks, different consolidation. But you still need some definition of some key terms. You still need to know what you relate your analysis to. So if you are doing multiple different analytical approaches in different departments of your client base, you need to know how they relate together. You need to know what is the definition of the client. When the client is distributed among various systems, you still need to know what do you mean when you say, okay, we have 15 million clients doing this or belonging to this segment. So we still need to define some business entities and basically create these kind of views and do the analysis on one of these views. It can be more than one. I can have one view for my risk management department. I can have different view for my web application or something. So multiple views are possible, but I still want to see, and basically the approach to create these multiple views would be exactly the same as creating a single view in traditional environment. The main parts of such solution would include, and the ones that I want to kind of cover, some integration of the source data. And there is actually a lot of tools, and you could see a lot of vendors doing some kind of integration. So loading data from various sources and putting them into one place is not really the issue, so I will not go into details here. The second part is basically matching and merging, finding the related entities that belong together and that we want to put together to have in our master data system. And then the last thing would be providing this data, because once you have this data calculated, these groups, these golden records, we need to be able to use them in any other process that requires this entity. This again, once we just decide how to store data, how it will be accessed, what will be the access path, it would be, I think, quite simple in the end. So the first step, I will just cover with one simple slide. Before we do actually integrate the data together from all the systems, we need to know what's inside. And I think it's very important. A lot of people are starting to playing with data without actually knowing what's inside. And the results are usually not very good. So the first step should really be profiling. This is just a sample image of our profiling tool. It doesn't have to be our profiling tool, but you should really look into the data before you decide to do some integration. The second part, and I think the only part that is really complicated, is the actual matching. In traditional environment, there are various expensive proprietary tools that come in here and that allow you to do some sophisticated matching with various algorithms. These tools do not work in Hadoop at this point. At least I do not know of any tool that would work perfectly in both traditional environment and in Hadoop. I've heard it mentioned on several of these conferences from people implementing some stuff from banks that have big Hadoop deployments and so on. So the common approaches today are either to do some simple kind of matching, which is basically just group by some key attribute, let's say group by my social insurance number or something. And that's quite easy to implement using MapReduce for batches, or if I want to do this online, I can just have some index built somewhere and I do simple lookup. Or when it's some complex matching, then that's the problem, and that's what I want to kind of cover. The problem is, as we will see. Okay, first I will give overview of these types of these complex matchings. They are typically either rule-based, meaning I define a set of rules that if the rule is true, like if, I don't know, the name of this person is at least 80% similar to name of other person, and they have the same phone number and something else, they are considered a match. So these are like the traditional approaches. The best thing about this is that you know exactly why the records were matched. You can have a nice audit trail knowing that if something was matched, it was satisfied by this rule and this rule was approved because something. So this is traditional approach in big enterprises that need really rigorous kind of matching. The other option that's more and more popular, especially in the big data world, is some kind of probabilistic matching where we just find similarities. We can have some machine learning algorithm that will help me find the correct weights. And it just compares all pairs of records, and if they are similar enough based on these options, then they are considered a match. The advantages are simply that if I have too many various sources, it may be easier to configure this part. The disadvantage is that it is kind of a black box. I just know that some score was bigger or lower than some threshold, and because of that it was matched or not. But it's difficult to track exactly what happened. And throughout time, when the data kind of develops, you have the algorithm, you have to keep track whether it still works or whether something changed in the data and it stopped working at some point. The last option is not really matching, but I've added here because I think it's very relevant in the big data sense. I can have actually the traditional kind of matching, maybe even the rule-based matching, on the main data streams that I have from my core system that is well-structured, that I know I can trust. And the other kind of data that I have some emails, I have some unstructured data that I need to access as well. I need to view it with my golden records, with my master records. So I can access this through just some search-based engine. It can be a full-text search, or actually we can look into like image search and audio search or something. But the text search sounds like most reasonable at this point. So it will just help me to narrow, like if I have this entity and I will search by its social security number and maybe telephone number and email, and I can look up all of the relevant documents that kind of relate to this person, detect why it relates, like where this string appeared, and I can put them next to them and I can have them available with each master record. The problems with the complex matching in Hadoop, there are actually several of them. Some of the traditional algorithms that are used, and it was actually a case of one of our algorithms that we use, that they cannot run in parallel effectively. There are pretty good algorithms that run on single machine very well, and they are very efficient, but they cannot scale out. Basically, it's not possible even on theoretical level. In some other cases, they scale out, but the complexity is still big. So somebody may say they scale linearly, but it means only that if I have, 100 million records, I have 10 nodes, the processing may take, 5 hours. If I have 20 nodes, it will take 2.5 hours. So it seems linear. But if I double the number of records and I don't have 100 million anymore, but I have 200, it will take quadruple the time. So it's not linear in relation to the number of records. So this is not really a good option for really big data neither. So these kind of algorithms only are good for relatively small set of data when we are talking about this big data thing. So typical solutions to this problem, it's either if the data is reasonably big, so I mean at most hundreds of millions of records, we can pick one of the traditional algorithms, for example the quadratic ones, and we can still run them on Hadoop, and they work quite well. There is actually a project in University of Leipzig, I think, it's called Hadoop, so it's the application on Hadoop, which runs this kind of probabilistic matching on Hadoop, and it scales nicely, but it's not as fast anyway. The other option, and that's the one that we use at the moment, is that we apply some heuristics to limit the candidates for the matching. So we apply some simpler rules that are easily scalable to limit the potential groups for the matching, and then we run maybe each-to-each matching on these smaller groups. For both of these approaches, the algorithms are quite complex, and as I said, the tools are not really ready at this point, but I would still recommend going with some of the tools. It's quite difficult to implement this from scratch. So this is an example of our kind of simple approach to limit the groups. It's based on simple matching, so matching by some key attributes, but it allows you to define multiple keys and apply them in sequence. So we have a couple of records, and the first step would be to match by some primary key. And by primary, I don't mean that it's unique, but in this case, it's like the first key that we want to use. So in my case, social security number. And I can see that two records have the same social security number, so they are put in the same group, and that's marked by this matching group ID. But there was this one record that didn't have a social security number, or maybe it originally had something in the social security number field, but it wasn't valid, so I had to remove it because it wasn't useful for the matching. The second step, I would take into account some other key, in this case passport number, and if it's possible, I will try to match the records that were not matched previously into the groups that I created. So in this case, I've added it to the first group as well. This way, if I define the hierarchy with multiple keys, I will get potentially quite big groups, and I can apply some more strict rules afterwards, maybe use some regular kind of matching, each-to-each matching, where I compare all the pairs and decide which of them are actual match and which are not. So this is just a summary. As I said, I can skip this slide. The only thing important here is that this basically translates to one MapReduce operation for each key if I'm doing it in batch. But if I'm doing this in online mode, if I've already done this on big load and I want to keep updating this kind of master database online, I can just index it properly based on these primary and secondary keys. And I can just look up by the index relevant records and do this processing on smaller data set. And this is again how it looks in our tool. Actually, this is our tutorial sample with all standardization and some matching and merging. So just some sample slides how it would look and how we actually started with some POCs. We have multiple sources of data here. And there is some kind of matching engine that will process them using MapReduce. And it creates an MDM repository, so some single view of the business entity, which will be stored back into HDFS, so it's a file. So this kind of bulk matching is batch only. It's really not that useful, but it was like just the first step to test, to kind of test whether the matching engine works as suggested. Oops. So, yep. Yeah, I guess my presentation was too boring, so. Yeah. So maybe it's time for some questions in the middle of my presentation. Perfect, thank you. So the second step after we've tested this was some kind of incremental matching, because typically you do not want to do this every day with the whole data set. Even though you have big Hadoop cluster, you still want to be processing some incremental data from some sources. So again, the first step was just to take the old repository, the old single view of our customers that we had, and some new extract. We find the differences, again, process it both in MapReduce, and create a new repository. So this is incremental, but again, not very useful. It's batch only. It needs to process all of the data that we have. So the next logical step was to include some kind of online mode where we could actually query the data interactively or update our master database with some online queries. At this point, it actually cannot live in HDFS anymore because it would be slow. Processing even small amount of records in HDFS would take forever. So we switched, and instead of using HDFS, we tried using HBase. It could be any other database that can live in Hadoop or in distributed environment. And that basically allows online access through some key. So in this case, when online request comes through, the matching engine first asks the repository for all records that share some key with this new record. The repository will return all of these relevant records back to the engine, and then the engine does the matching as if this was the full data set. And then it detects whether the matching changed, because the matching can change in time when the input record was some kind of update. And it stores the results back into this online accessible database. And in the end, the complex scenario had to support both batch and online mode. So basically, there are just two versions of the same logic. One runs using MapReduce, one runs this kind of non-parallel online mode that can run in parallel. There can be multiple online requests run at the same time. But it really doesn't make sense when I'm processing 5 records to run it distributed on the cluster. So the one online request would be processed only locally on one machine. So basically, we have some input. We determine the size of the input, and if it's small enough, we process it locally against the distributed online accessible database. If it's big, we process it using MapReduce. And then there was actually one more step for this part that we found out that was good optimization. Since the matching itself on this big data set can be very time consuming, we've added a step called delta detection here, which basically, if I have some full extract, I get hundreds of million records from some system that I need to process, but I know that I have processed this data set a week ago. So probably most of the records in this big data set did not change in the last week. So I first just load all the data from the system from my repository, detect which records changed. And if it's less than some amount, I can still process it in the online interface and not running the full MapReduce. So the key idea is, even though this is MapReduce as well, this one is actually quite simple. It's a join, and I just detect the changes. And this one is actually doing the whole matching thing with all of the rules that are defined. So this MapReduce can take, 10, 20 times more than this one. So after we have this, we have a central repository with our single view of our business entity. We can create the various services on top of it. In our case, we want to be able to do some inserts or updates. That's basically the online service I was showing. We get a record on input. We detect whether there are some relevant records in the database, maybe the same records with some older timestamp, and we do the matching process again. The very typical service we call identify. is quite similar, but we do not want to store the results. It's basically the case when we get a new entity coming in, but we are not 100% sure whether it's already there or not. So this basically detects when, I don't know, a new client comes into, or a person comes into a bank, and they say, I want to create a new account. So we type in their credentials, and this service would look up whether this person is already our client or whether it's already in our system or not. And it basically returns the master entity from the database if it's already there. Another typical functionality would be search. In this case, we would have to have some full-text search engine or some kind of search engine available as well, which is these days very easy to do. And it might make sense that we want to find some master records only based on some partial matches and so on. So for that, the full-text search is a very reasonable option. We want to be able to fetch master records because some system would have referenced the master data and have some data stored locally because maybe they cannot store something in the MDM hub because of legal reasons or something. So we will distribute the unique ID of this master entity. And if the system needs to work with the current version of the master entity, it can fetch the details by ID. And we need some other systems to be able to go through all the master data. So let's say I want to do some analysis, some data mining on top of a whole set of my master data, or maybe a subset, maybe some segment. We need a scan option as well. All of these are nicely supported except for the search by HBase kind of database or Accumulo or something like that. For search, we would need additional tool as well. And that's everything that I have prepared for today. If there are any questions, I can answer them now, or you can actually visit us at our booth.